the neuroanatomy for step one, high yield review for neuroanatomy. This is the learning objective for this presentation, and these are the topics that I'll be covering. So I won't be covering them in this order. What I will do is I will start with spinal cord, cranial nerves, and brainstem, as well as cerebral cortex. Those are the four highest yield topics for neuroanatomy for step one. So I'll start with those, and then later on I'll go over the rest of them. They are important. They're not as high yield, so I kept them to last. And I'll end with the limbic system and the diencephalon, some embryology, bits and pieces that will seem a bit siloed, but you may actually see questions about those topics in the test. So I kind of picked whatever was most important from those topics in your book, and I'm going to be covering them today. So let's start with the spinal cord over here. So what will I oh, before I start, any other questions from anybody about what we're going to be doing today? Okay. Looks like everything is good. So I'll start with the spinal cord tracts. For spinal cord tracts, we're going to be talking about the motor pathways and the sensory pathways. For motor pathways, I'll talk about the lower and the upper motor neurons and differences between them and differences in symptoms that you may see in each of these with damage to each of these. We're going to talk about the corticospinal tract, which is the tract that has all these neurons. And for sensory pathways, I'll talk about the dorsal column or medial lemniscal system. This one's going to be for um, um, touch, vibration, and proprioception. I'm going to be talking about the spinothalamic tract, which is for pain and temperature, and I'll be talking about the spinocerebellar tract. Very little, actually. That one I will cover a bit in more detail in the cerebellum part of this presentation. This picture is from your book, and honestly, it's one of the most helpful and informative images for spinal tracts you'll ever see, really. It's color coded, it shows you the decussation, it tells you the modalities, and it shows you the laterality of the symptoms. I'll go over this diagram several times during this presentation. So just as an intro, I'll let you know what you can see in this diagram. This is the spinal cord over here, and then brainstem and cortex is going to be higher up. We have several tracts. We have the corticospinal in orange, so this one is moving downwards or descending. We have the medial lemniscal in this purple over here, and this one is ascending towards the brain. We have the spinothalamic tract in light blue or teal over here, and this is ascending as well. And lastly, we have the spinocerebellar tract, also ascending here. I won't talk too much about the spinocerebellar. This has a lot to do with the muscle spindles and information about to what extent is each muscle is contracted. And it's always ipsilateral. It's one of the easiest ones to remember because it's always ipsilateral. The other ones are different because they decussate. Now, what does it mean to decussate? To decussate means to move from one side of the body to the other. So, for example, the corticospinal tract, it starts over here in the patient's right primary motor cortex, and then it will decussate, move to the other side, to the left side, in the medulla, and go all the way down to the muscles it needs to innervate. Okay, so let's start with a corticospinal tract, as I said right now, from the cortex through the thalamus, all the way down to the brainstem, and then it decussates in the medulla all the way to the other side of the body, and then it just leaves the spinal cord wherever it needs to. So these ones will go to upper limbs, probably these ones will go to lower limbs, and we do have two neurons in this pathway. We have an upper motor neuron that starts in the cortex, Goes all the way down until it gets to a synapse, and then it synapses with a lower motor neuron. The lower one is going to be the one that exits the spinal cord and then innervates whatever muscle it needs to innervate. So these are the two neurons, and the cassation is way high up in the medulla over here. Let's look at the medial lemniscal system. It has to do with touch, vibration, and proprioception. This purple one over here, right next to the orange one. This one is coming from the body. It is an ascending pathway. So from the body, let's take the lower limb as an example over here. And then it goes into the spinal cord all the way up here, and then it decussates again. It's very similar to the corticospinal tract in the medulla. So it goes to the other side to the primary somatosensory cortex in the cerebral cortex. And lastly, we have the spinothalamic tract. Notice the difference over here. This one is also coming from the body. Let's take the lower limb as an example again. Coming from the body to the spinal cord, but look at this. It decussates immediately. So it enters the spinal cord. First of all, it decussates, and then it starts climbing upwards toward the cortex. So very different from the other two, which is why we see the following in terms of symptoms. Let's say this person over here has a laceration or a lesion at T10, which is about the waistline over here. There's a cut over here through half of the spinal cord, and now we're asking, where are we going to see symptoms? Where will we have motor weakness? Where will we have a deficit in cold and pain, temperature and pain sensation? And where will we have touch, vibration, and proprioception deficits? And here's the answer. So if the lesion is on the left side, anywhere below this lesion, and this is important, below, because at the level of the lesion, it's going to be different. Anywhere below this lesion, we'll see ipsilateral symptoms for motor and touch, vibration, and proprioception for medial lemniscal system. But anywhere below this lesion on the contralateral side, we'll see deficits with pain and temperature. Why is that? So see, the lesion is over here on the left side of the patient. Which fibers are found over here? Well, for corticospinal tract, it started on the right, moved to the left, went down, and then it was cut. So it's not going to get to the left side. It was supposed to go to the left lower limb. It's not going to do that. So above this lesion, ipsilateral deficits. Let's look at the medial lemniscal system for pain, vibration, and proprioception. It started from the thigh, let's say, for example, right? On the left side. Started to climb, was supposed to decussate over here. Never got here, though, because the lesion is over here. So again, we have ipsilateral deficits. Lesion on the left, deficits and symptoms on the left. But for the spinothalamic tract, it's very different. It's the opposite, actually. It's contralateral. Let's see why that is. If the cut is over here, what fibers do I have traveling over here? Well, actually, those are fibers from the other side because they decussated really early on. So actually, a lesion on the left side means deficits from the right side of the lower limb for pain and temperature specifically. Lastly, let's talk about the actual level of the lesion, T10. This line over here is red because every single modality at the level of the lesion is going to be deficient. And the reason is because the nerves themselves come out of the spinal cord, or in for that matter, at a certain point, and when they do, in and out over here, all of them are going to be deficient. So even this spinothalamic tract that goes into the spinal cord and decussates immediately, there are going to be some fibers over here from the left side of the patient as well, right? Those ones ipsilaterally are going to be deficient because this is where they go into the spinal cord and there's a lesion here. Lastly, I will let you know that the spinocerebellar tract, that one is going to be ipsilateral all the time because these tracts do not decussate. So any information coming from the spinal cord to the cerebellum simply doesn't decussate. And if there's a left side lesion, there's going to be left side symptoms, and right are going to be seen on the right. Before I go on, any questions about this specific table? And if you didn't get it yet, I am going to go over it multiple times during this session today. So don't worry about it. But if there are any stressing issues about this, I will be happy to address them. Okay, so let's go on and look at what we have here.